Good morning to everyone. So, in the last class, we have seen the operating system performances and a typical operating system structure and what are the function calls when we go for MC680 processor. So, in this class, we are going to see about what is meant by the real-time operating system and then performances. A characteristics of real-time operating system is it define response to time external stimulation. If a peripheral generates an interrupt, a real-time system will acknowledge and start to service it within a maximum defined time. So when we go for the operating system and the real-time operating system, that is the difference between the operating system. It's not a time specific, but a real-time operating system, it will be serviced within a maximum defined time. So that is the difference between the operating system and the real-time operating system. So the next definition for the real-time operating system is to prevent a system from power failure usually needs to guarantee response time so that a short time between the recognition of actual power failure can be used to store vital data and bring the system down in a controlled manner. Okay, so that advantages means the power failure used to need guarantee response to that particular short time between the recognition and actual power failure when we go for this real-time operating system. That is the difference between the operating system and the real-time operating system. Okay, it's a operating system is not a time specific, but the real-time operating system will be a time specific. So when we go for this general purpose real-time operating system means there's a Windows. So these are all the examples for the general purpose operating system. When we go for the real-time operating system, it's a QNX, VxWorks, PSOS, Windows CE. So these are all the real-time operating system when we go forward embedded systems. Okay. So next we are going to see about the what are the mean by the process and process control block. Okay. So a process consists of sequentially executable program and state controlled by an OS. The state during running of a process is represented by the information of process, structure data, objects and resources. A process runs on scheduling by OS which gives control of CPU to the process. Okay. So generally a process consists of a process control block. So that process control block represented by the information of process state, process structure data, objects and resources. Okay. So all the process will be scheduled by the OS and it will give control to the access of that CPU performances. Okay. So process is a process 1 and process 2 and process n process will be available in the CPU scheduling process, and the task the next subtask will be a thread. So thread will be a lightweight entity. So process it will be the process and the subtask will be the thread. A thread consists of sequentially executable program under state controlled by a OS. So the state information of a thread is represented by thread state started, running, blocked, finished. So thread is a lightweight entity. So next one we are going to task. We are going to see the task. So what is meant by task? The task is defined as embedded program, computational unit that runs on a CPU under the state control of kernel of an OS. So it has a state which at instance defined by the status running, blocked, finished. So generally a task has three basic blocks. The first one is running, the second one is blocked, the third one is finished. Okay. So these are all the main three status of one particular task. Okay. So these are all the task block diagram. So initially the task will be in idle state. When the created task, it will be ready for to execute. So after receiving the signal or message from the CPU, it will go to the next process that is called running. Okay. So after the signal which is receiving from the CPU, it may be a blocked or it may be a still continuing. Okay. So these are all the again the block state is executing in the sense it will complete in an idle state. Okay. So the next one is task and task state. So generally a task is having task ID, task context, program counter, stack pointer, CPU registers, process state registers, task priority and task context initialization. Okay. So a pointer to a startup function, a function runs a task from this address. A pointer to the context data structure, the structure includes the process registers and status tokens. a pointer to a new object which will be run next, a pointer to the stack of a previous task object. So generally a program counter will store the address of next instructions. So the stack pointer will store in the address in the format of push and pop instructions. So all the task will be identified by the task ID. So based on the priority, it will execute by the processes. Okay. So these are all the tasks and task state. So the next one is semaphore and interrupt service routine. So in this class we have seen the task state, and what is the real-time operating system and operating system differences. So in the next class we are going to see about the semaphore. Thank you.